Now, I told you previously that there was more than one way to talk about the center of a distribution. Before, we talked about the median, which was the middle. The center and spread of a symmetric distribution is a little bit different. So instead of the median and instead of the range or the IQR, we're going to look at different values, which are the mean and the standard deviation. So again, I want to note that this is for symmetric distributions. So this is for something that looks symmetric. So on a normal curve, which we'll talk more about later in this class, it would look like this. I would use a mean and a standard deviation. If I have something that's skewed, I wouldn't want to use the mean and standard deviation. So the mean is just the average, and most people know this already. So the average of the data is called the mean. You're just going to find the sum. So this scary looking figure here just means the sum of all of the values that you have divided by n, which is the number of values that you have. So using a data set here, I've got 1, 2, 3, 4, 5 values. I'm going to add up those values and divide it by 5, and that gives me the average. So I would say the center of this data is about 25. Now before, I would have written these as 17, 22, 23, 29, and 34, and then said, well, the center is 23. So this is the median, which is one way to describe the center, and this is the mean, which is another way to describe the center. So the big question is, when do we use which one? If I know that I can use the mean or the median, how do I choose the most appropriate value? Well, if we're dealing with a symmetric distribution, if it's truly symmetric, exactly the same, the mean and the median are going to be exactly the same value, although typically then we would use the mean. However, if I'm dealing with an average, remember mean is an average, and if I have whatever my average is and I add a very, very large value or a very, very small value, that mean is going to be pulled in whichever direction. So if I added a very large value, that's going to make my mean a lot larger and actually not very representative of my population. If I have a very, very low value compared to all of the other values, then it's going to pull my mean lower and again not represent the data as well. So therefore we use the median because it's a better measure of center for skewed data. Because remember, to find the median, we're just counting in from the outside. So if I have a very large value or a very small value, they're just sort of tossed aside because I'm just counting in to get to the middle. So rule of thumb, if you're dealing with anything symmetric, use the mean. If you're dealing with something that's skewed, that has an outlier, you use the median. Now, variance is another way to talk about spread. So we talked about spread before as the range. And we also talked about spread using the IQR, the interquartile range, how far the two quartiles are from each other. So now we're going to talk about the variance, and the variance is a measure of how far the data is from the mean. And the difference from the mean would just be taking our value, so this is our data value, and y bar in statistics is the mean. So whenever you see y bar, or sometimes you'll see it as x bar, that means you're talking about the mean or average of the data. Now sometimes if I subtract those two values, it makes sense that sometimes I would get a negative value and sometimes a positive value. So obviously we like to deal with positive values, so to make it positive we're going to square it. And then we're going to basically find all of the sum and then average them, except instead of dividing by n, we divide by n minus 1. So whenever you see the s squared, that means that's the variance. Now the variance is not something we use very often. Most of the time we use the standard deviation, which is the square root of that, which is s, and that's what we're going to use most often. So let me show you an example of how it works. But basically we're talking about spread. Standard deviation tells us how spread out from the mean are all of our data values. So here's a way that we would do it by hand. I do believe I did ask you on one of your case studies to do it. So let's talk about how we found it. Here's the 5 values that we had used previously, and I found the average of these by adding up all of those values and dividing by 5, and that value was 25. So if I'm doing this by hand, I'm going to take each value, 17 minus 25 or 22 minus 25, etc., and I'm going to subtract 25 from it, and then I'm going to square it. So here, -8, when I square a negative, it becomes positive. -3, when I square it, becomes positive. 9 squared, still positive. Add up all of those values. That's the sum of my deviations. And then I'm going to divide it by n minus 1. There were 5 values, so 5 minus 1, which is 4. So my variance is 43.5. So typically the way I would show this by hand is I would take 17 minus 25 squared plus 22 minus 25 squared, etc., blah, 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 that equals the variance. And then to find the standard deviation, which I would write SD, or sometimes I write S, then I would take the square root of whatever I get there, which in this case was 43.5, and that would be my standard deviation. And we'll talk more in depth about standard deviation, but this value means that that's how far this is spread out from the 25. So the 25 that is my center, so if I were going to draw a curve, 25 would be in the middle of my curve, and then one standard deviation would be 6.595 more than that, and then 6.595 more than that, and 6.595 more than that, etc. So a little bit more about the standard deviation. This tells us the deviation from the mean. So how far from the mean, from the center of our value, is the rest of our data. Can it ever be a negative number? Absolutely not. Because remember, when we were finding the standard deviation, we squared everything to make it positive. And so we had a variance that was positive, and then we took the square root of a variance, which of course is also a positive number. So no, it cannot be negative. Can it be 0? Yes, but it's probably not going to occur very often. The only time you're going to have a standard deviation of 0 is when all of your data is exactly the same. So if I had a data set of 10 values and all of those values were 7s, then there's no deviation from the average of 7 because everything is 7. I don't know how many that is, but you get the idea. The smaller the standard deviation, the more or less spread out the data is from the mean. So a small standard deviation means everything is closer to the mean. So that would be less spread out from the mean. So if I have a large standard deviation, it's further out from the mean each time.